Hi guys, welcome back to the QSC channel. Today I'll be explaining the mechanics quiz for this week. Okay, let's start. So a body A exerts a force on body B denoted by FAB, and body B exerts a force on body A denoted by FBA. Which of the following statements are true? Okay, first of all, these two forces are obviously action and reaction. And what we know about action and reaction is that they have equal magnitude, they occur in opposite directions, and they act on different bodies. You have to memorize this. Okay, the figure below shows a trolley accelerating towards the right with a mass against its front surface. What's the minimum acceleration it should have for M not to slip? And knowing that the coefficient of static friction is 0.4. First of all, we need to draw the free body diagram. It should look like this. The weight is down and the normal isn't up, it's to the side because the surface is here. Okay, and the friction should be opposite to the motion. If you have a block that's against a wall, it's probably gonna fall, so the friction is gonna be up to stop it from falling. Okay, so the motion is to the right, so N is equal to MA and F is equal to the weight, right? Because they're not moving, so there's no acceleration. Okay, so the weight is equal to mg, which is 10m, and we know that the friction is also equal to mu n, and we know mu is 0.4. Yeah, so we write F is equal to 0.4 n. So we can say that 0.4 n is equal to 10m. And what do you know about the normal n? It's ma, so you can write 0.4 ma equals to 10m. Now you can see we can cancel the m's, so a is equal to 10 over 0.4, which is equal to 25 meter per second square. Okay, so this question it's a little weird, but all you need to know is that the resultant has a range. It has to be greater than the subtraction of the two forces and less than the addition of the two forces. So you have to check with each one. 8.5 minus 8.5 is 0, and then when you add them it's like 17, and this is true, so it can produce this resultant. Now with 12 and 3, let's try 12 minus 3, it's 9. 8.5, wait, and then 15. Now, is this true? Is 8.5 greater than 9? No, so it cannot produce this resultant. And if you check the other ones, you find that they can produce a resultant. Okay, now this question. When a child is pulling a sledge up an icy track, the rope snaps. Neglect friction and air resistance. Which of the following best describes the motion of the sledge immediately after the rope breaks? So what they want you to focus on is immediately, because it does stop and it does slide backward, but immediately after it just keeps moving for a bit. It moves forward for a bit before stopping. So obviously it's gonna have momentum, so it's gonna keep moving forward. Okay, a body is subjected to a constant net force. Which of the following statements must be true about its motion? At a constant speed, no. Definitely not, because it accelerates. But its acceleration changes, no, because it's a constant force. The body moves in a straight line, but speed may vary. Yes, its speed may vary, yes, but we don't know. It couldn't be in a circular line, not a straight line. So no. And this one also straight line, so no. So, and this is the only correct one, which is a constant acceleration. Okay, a body of mass 2 kg is accelerated from rest by a steady force of 5 newtons. What is the speed of the body after it has traveled a distance of 40 meters? So they want the final speed, and we have the mass, force, and the displacement or distance, whatever. Okay, we can use, since we have the force and the mass, we can use F equals ma to find the acceleration. So we'll have 5 is equal to 2a, the acceleration is equal to 2.5 meter per second squared. Now we have acceleration, we have distance. We can use the UARM rules to find the final velocity. I'm gonna use this one, which is v final squared minus v initial squared equals to 2a delta x, because this one doesn't have the time and we're not given the time. The final is what we want to find, so we keep it. And the initial speed is 0 because it's from rest. So v final squared minus 0, so we keep it, equals to 2a delta x. 2 times 2.5 times 40. And you get v final squared equals to 200, which will get you like 14.14, which is the same here. Okay, this question is just wrong. I've tried every single way that it's literally wrong. I think it's because they didn't give us friction, but yeah, it's wrong. Okay, child A and child B are playing tug of war, each pulling on opposite sides of a rope. When child A pulls on the rope, a tension force is created. Which of the following best describes the reaction force to the tension in the rope caused by child A's pull? Okay, so child A pulls on the rope, so you just reverse it. Rope on child A, which is this option, rope on child A. Okay, this one is easy. You just need to look at the free body diagram. Obviously the force is going to be like this because it's attracted to it. It's a positive sphere, and this is a negative one. And you can see that these are mostly the same, but they didn't mention something like this one doesn't have friction, so it's wrong. This one doesn't have normal, and so on. So you just need to pick the one that is the best one, like choose everything. Okay, a man pulls a crate across a rough horizontal floor at a constant velocity by applying a force P at an angle above the horizontal. The other forces acting on the crate include its weight, the normal, and the friction. Just the following about statements about the magnitude of these forces is true. So first of all, we need to draw the free body diagram. wait. Okay, now we project P. Let's say this is x and this is P cosine x, and this is P sine x. Okay. Okay, first one, f is greater than P. We know that f is equal to P cosine x, right? Because it's a constant velocity. P cosine x is less than P. We know this because cosine of anything is always like 0 point something, so it's gonna be less. So if P cosine x is less than P, we can just replace it with f. So f is less than P, not greater. So this is the one that's correct actually. Okay. Now the normal and the weight. We know that normal plus P sine x is equal to the weight. What does this mean? The weight, the whole weight is equal to the normal plus something else, right? So the normal, it's small, it needs something else to equal the weight. So the weight is greater. Yes? So if this was like 1, this would be 2, this could be 3, like, yeah, just imagine it like that. Okay. So this is correct, the weight is greater, they are not equal, and these are not equal as well. Okay. Two boxes, each with a mass of 10 kilograms, are stacked on top of each other inside an elevator that's moving upward at a constant speed of 1.5 meter per second. What is the normal force exerted on the bottom box? Okay, I know they said bottom box, but I'm gonna draw the free body diagram of the top box first to make you understand. First of all, this is just a general picture of how to look like this. 10 and 10, and it's going up. Yeah, this is the top box. So the free body diagram for it will be, first of all, the normal of the box. Okay, this is important, and the weight. Okay, that's not important, we're not gonna use this. What we're gonna use is the reaction of this. In the bottom free body diagram, you'll find there's a weight, there's the normal of the ground, and there's also the reaction of NB. Since the bottom block exerts a force on the top will exert the same the same force in the opposite direction. So since this is up, it will be down, and we'll call this R and B. It is equal to NB, but it's just in the opposite direction. Okay. And what do we know about NB? NB is equal to the weight. Since it's at a constant speed, NB is equal to mg, which is 10 times 10, which is 100 newtons. And now we can work here. Normal of the ground is equal to the weight, which is 100, plus this, which is 100. So you get 200 newtons. So the trick here is just to know which forces, which is the reaction. Yeah. Okay. Block of mass m hangs in equilibrium, supported by two ropes as shown below. One rope is fastened horizontally to a wall and has a tension of 20. The other rope is fastened to the ceiling, makes an angle of theta with the ceiling and has tension of 50. Okay. Now ignore this small rope, okay? Just imagine it's not there. It's gonna be like this, the free body diagram. The weight mg. Let me just put 10m. 50 and 20. This theta is equal to this. Yes, okay, so this theta is equal to this theta, which I'm gonna draw here on the free body diagram. Now you can project this force. It will be 50 cosine theta, and here 50 sine theta. We don't know m, so we're not going to use the vertical, we're going to use the horizontal. Since it's stationary, it's not moving, 50 cosine theta is equal to 20. So cosine theta is equal to 2 over 5. So theta is equal to cosine inverse of 2 over 5. Another way to say cosine inverse is arc cos, which is what they said in the answers. See, it's arc cos 2 over 5. Okay, 3 blocks of masses m, 2m and 3m are pulled across a frictionless surface by a horizontal force T as shown in the figure. Which of the following is true about the tensions T1 and T2? Okay. So first of all, start the free body diagrams. So here, there's only T2, the weights, and the normal, which you're not going to use in this example anyway. Here you have T1 and T2, and the weight and the normal. And here you have T and T1. Okay. First of all, let's start with T2, which is the easiest. T2 is equal to MA immediately, because it's the only force. Yeah. So that's the only thing here, so we move on to the next one. You'll have, since it's moving this way, it's gonna be T1 minus T2 equals to MA, and we know T2 is MA, so we can substitute it here. T1 minus MA equals to MA, so T1 is equal to 2MA. Okay, let's start it here. T1 equals to 2MA. Now here T minus T1 is equal to 3MA. Okay. T1 is 2MA, so T minus 2MA equal to 3MA. Wait, I just realized that I did a mistake. Up here, T1 is supposed to be 3MA because T1 minus T2 should be equal to 2MA, and T2 is MA, so this should add up to 3. Okay, my bad. Now T1 is equal to 3MA, and we can substitute T1 here. So T minus 3MA equal to 3MA, so T is equal to 6MA. Now we can see they want everything to be like in terms of the things. So T2 is ma, then it then T it's 6 MAs. So you can say that T is equal to 6 T2, and the same thing for T1. T is equal to 2 T1s, right? Because 3 times 2 is 6. Okay, so if you combine these all, it's gonna be T is equal to 2 T1 equals to 6 T2. Okay, so basically what they want is they want you to make T in terms of everything. So yeah. Okay, a pendulum consists of a bulb turned from a light string attached to the ceiling. Pendulum is released from rest at the position shown in the figure. Which of the labeled arrows best shows the direction of the net force? Okay, there are two forces acting here, the weight and the tension. So the resultant will be anywhere in between here, right? And we can see that the weight is like, this angle is like really small, it's not gonna affect it that much, right? So it's gonna be more leaning this side rather than this side. It's gonna be more down. So it's 3. It's like, it's very weird for it to be 2 because like the weight has to like jump up over there. So it's 3. Okay, this question, they give you random values to confuse you. It's just a memorization question. The inertial mass is always equal to the gravitational mass of any object. Okay, here the graph below shows the variation of a force stretching a nonlinear spring with the change in its length x. Select the correct graph that represents the variation of the force exerted by the spring. So it's the same thing, but it's negative. So not this, not this, and you don't flip it. That's wrong. It's still gonna have the peak at the same point, just down. So just flip it about the x-axis. Block of mass 5 kg pushed along a rough surface. Coefficient of friction between the block and the surface 0.3. And what's the pushing force needed to accelerate the block 4 meter per second? So it's pushed by a force. There is friction. There is a normal and there's a weight. First of all, let's start with the easy ones. Weight is 50 newtons, 5 times 10, and the normal will be the same 50 newtons. Now from the normal and the coefficient of friction, we can find the friction. So friction is equal to mu n, so 0.3 times 50, which is equal to 15, I think. Yes, it's 15. Okay, now we have the friction, we can solve. F minus 15 is equal to ma, which is 5 times 4. So F is equal to 20 plus 15, which is 35 newtons. Two particles of respective masses m and 3m are connected by an inextensible string S and pulled by a force F along a rough horizontal surface. The system then accelerates at a rate of 6 meter per second squared, and the coefficient of friction is 0.6. Okay, so let's start with M, it's easier. M has a weight of mg, which is 10m, and a normal friction and a tension, let's call it ts. Okay, the normal is equal to 10m. This is easy, since it's not moving upwards. And now the friction is equal to mu n, and mu is 0.6. 0.6 times 10m, so it will be 6m. And is it accelerating? Yes. Okay, so now we work with the horizontal. Ts minus 6m, the friction, is equal to ma, which is m times the acceleration 6, so 6m. So the tension is equal to 12m, which is what they want here. They say it's pm, so p is 12. Okay, now the next thing they want to find is magnitude of F. By the way, F is only on 3m, not on m. This is important to know. Okay, now we do 3m. Now the weight is 3m times 10, which is 30m, and the normal is the force, there is friction, and there's also the tension. The tension, we know it's 12m. The friction will change since the normal is changing, so normal is 30m, and the friction will be equal to 0.6 times 30m, equal to, which is 18m. And now we can solve. So F minus 18m, the friction, minus 12m, the tension, is equal to 3m times 6, which is 18m. Yes, 3 times 6, 18. Okay, 18m.